Okay, so in this lecture I'm going to talk about naming cycloalkanes. I already talked about this in class, but I thought it would be good to have sort of a record of this. So we're going to use the same principles and the same ideas and terms that we used when naming alkanes. So it's just that when we talk about cycloalkanes, we're talking about structures that are single bonded carbons, so no carbon-carbon double bonds or triple bonds yet. That's why we're calling them cycloalkanes, in a ring structure. So in a 5 or 6, or sometimes you can even see 4-membered rings or 7-membered rings. Let's see if I can draw that well. Oops, that was a little weird. So sort of like that. So our first rule for naming cycloalkanes is we have to, as before, find the parent chain. But the parent chain is always going to be defined as the ring. The ring will always be the parent name. So if we have something like this, this has 6 carbons. 1, 2, 3, 4, 5, 6. So we would call it a hexane. But because it's in a ring, it's all connected, we call it cyclo. So that's how we change the parent chain name to indicate that it's a ring. So cyclohexane, this, of course, would be a cyclopentane. This would be cyclobutane, and so on and so forth. So with that in mind, we now talk about substituents. So if I have an alkane, we call this cyclohexane. If it has a substituent, like a methyl group, then we still name it methyl cyclohexane. Now the numbering is a little bit different because we don't have an N to start from. So what we do is we can start anywhere on the ring, but as before we have to number such that our substituents have the lowest possible set of numbers. So really with this there's only one choice. We start with the 1 on the methyl and we go around. It doesn't matter which way we go. We can go counterclockwise or clockwise. In this case we get the same either way. It would be 1 methyl cyclohexane. However, that 1 is actually unnecessary because there is only one possibility. If you have a cyclohexane with 1 methyl, it must, by definition, be at carbon number 1. So if there's just one ring substituent, no number is necessary. When I have 2 or more substituents, we number beginning with the substituent of higher alphabetical priority, except we only use this as a tiebreaker. So again, I believe I mentioned this in class, if you have a methyl, methyl, and an ethyl, you're still going to start with one of these methyl groups because we want the numbers to be as low as possible. 1, 2, 3, 4, 5 gives us the lowest possible chance. If we went the other way, starting with 1, 2, 3, 4, 5, it wouldn't be as good. Likewise, if we started with the ethyl group, we would have 1, 2, 3, 4, which isn't as good either. So 1, 2, and now I'm getting too many numbers here. Our best option is to have 1, 2, and 4. So this becomes, our substituents are 1, 2 dimethyl, to indicate the 2 methyl groups at carbons 1 and 2, 4 ethyl. Now the order is still the same. We still put them in alphabetical order regardless of what number comes in front. 4 ethyl, 1, 2, dimethyl, and I round out of room, cyclohexane. So that's the basics of numbering. So with 3 or more substituents, like I showed, you get the lowest set. With 2 or more, the only possible option, like if I have a methyl and an ethyl, right? One of these will be 1, and the other will be 3. The only way to break the tie is by alphabetical priority. So the ethyl will come first. So it would be 1 ethyl, 3 methyl, cyclohexane.